All right, so picture this. You're trying to have a video chat with someone on like a lunar base, but your connection keeps dropping out. Super frustrating, right? That's just one tiny example of the kind of problems that our satellite networks are facing these days. And that is why this document that we're diving into today, Galaxity, is so fascinating.
Yeah, it's not just about, fixing a few dropped calls or whatever. This document is laying out like a really ambitious vision for a total overhaul of how we use space, powered by this really mind-blowing mix of technologies. We're talking quantum computing, we're talking artificial general intelligence. That's AGI, by the way. And of course, good old-fashioned classical systems, all working together.
Right. It is a wild mix. And to be honest with you, when I first saw the sales document, I was a little skeptical. Like, is this really going to happen? But then I started digging into the details, and I got to admit, they've got me hooked.
Yeah. Well, before we get too carried away with all the, futuristic promises, I think it's important to sort of ground ourselves in the problems that Galaxity is actually trying to solve. And honestly, the challenges that they outline are pretty sobering.
Okay, so let's unpack this. So we've got the obvious one, scalability. We're launching more satellites every year. And managing that many objects whizzing around the planet, it's a logistical nightmare. It's almost like trying to conduct an orchestra in the middle of a hurricane.
And it's not just about the numbers either. There's also this looming threat of quantum computers, which could make our current encryption methods completely useless. Imagine a world where all satellite communications are just vulnerable to hacking. It's a recipe for disaster.
Not to mention the growing problem of space debris. All those defunct satellites and rocket parts are basically creating a cosmic minefield up there. It's like a slow-motion chain reaction waiting to happen. One collision could trigger a cascade, creating even more debris and making space even more unusable and more dangerous, obviously.
Exactly. So Galaxity is not just about building a better satellite network. It's about ensuring the long-term sustainability of space itself.
Okay, so they've painted a pretty bleak picture of the problems. So let's get to the good stuff. What does Galaxy actually propose? What's their big solution?
Well, they're envisioning a network that is seamlessly integrated from Earth to orbit and beyond. A network that's not only faster and more reliable, but also inherently secure, even against the threat of those quantum computers. And they think they can do this with this hybrid system they're proposing.
Okay, let's break down this hybrid system because it is pretty key to their whole vision. They're talking about quantum computing, AGI, and classical systems, all working together. Sounds like a recipe for some serious technological synergy. But I'm curious, why not just focus on one of those technologies? Why the need for all three?
That's a great question. And it gets to the heart of why Galaxity is so intriguing. They're not putting all their eggs in one basket. Instead, they're acknowledging that each technology has its own strengths and weaknesses. Quantum computing, for example, is fantastic for handling incredibly complex calculations, but it's not necessarily the best for like routine maintenance tasks.
So it's like they're assembling like a dream team of tech, each with its own superpower.
Exactly. Quantum computing provides that raw processing power, capable of crunching massive amounts of data and optimizing everything, from satellite trajectories to communication protocols.
And the AGI, that's where it gets really interesting, right?
Absolutely. The AGI is like the conductor of this whole technological orchestra. It's constantly monitoring the entire network, learning from the data, predicting potential problems, and making decisions in real time to make sure that everything runs smoothly.
So instead of waiting for commands from Earth, the network can basically think for itself, adapting to changing conditions and even preempting issues before they arise.
Precisely. It's a level of autonomy we've never seen before in space. And then underpinning all of this, you have the classical systems. They provide that reliability, the redundancy, the fail-safe mechanisms to ensure that even if the quantum computer or the AGI encounters a problem, the network remains stable.
Okay, I'm starting to get the picture, but this all sounds incredibly ambitious, bordering on science fiction, honestly. How do they actually plan to make this a reality?
Well, they've laid out this 5-phase plan, which we'll delve into later. And to be fair to them, they're very upfront about the fact that some of these technologies are still in the early stages. But they believe that by taking this phased approach, they can gradually build up to their grand vision.
All right, let's dive into those phases because I'm dying to hear about what they've got planned. But before we do, I think it's worth emphasizing just how radical a shift this would be.
It's not just about better internet in space, is it? This is about fundamentally changing how we interact with space, how we use it, and who has access to it. The implications are huge.
Absolutely. So with that in mind, let's take a closer look at their roadmap for building Galaxity, because it gets pretty wild.
Welcome back to our deep dive into Galaxity. Last time we laid out the problems this proposal is trying to solve, and the key role this hybrid system of quantum computing, AGI, and classical systems is supposed to play. So now let's actually get into the details of how they plan to build this thing. They've got this 5-phase rollout plan, which on the surface seems pretty logical, but when you start looking at the specifics, well, it gets pretty mind-boggling.
Great. The devil's in the details, as they say. So let's unpack this roadmap, starting with phase one. They call it concept design. Sounds pretty straightforward. What are they actually doing in this initial phase?
It's about laying the foundation. It's where they refine the overall architecture of the network, nail down the specific technologies they'll be using, and start identifying the most promising use cases. Think of it like an architect, drawing up blueprints, before breaking ground on a skyscraper.
Okay, so big picture stuff. But then they move on to phase two, technology prototyping. And this is where things start to get a little more hands-on, right?
Absolutely. This is where they move from the drawing board to the lab, putting the pieces together, testing individual components, and seeing how well these different systems, quantum, AGI, and classical, actually play together. They even mention running simulations to test how the network would respond to various scenarios, like solar flares or cyber attacks.
So they're not just building hardware, they're also developing the software and the algorithm that will
Yes.
allow the AGI to learn and adapt.
Precisely. And it's in this phase that they also start experimenting with some pretty cutting-edge stuff. They mentioned testing quantum key distribution protocols, QKD for short, in orbit.
Now that's something I wanted to circle back to. We talked about how Galaxity promises unbreakable communication, and this QKD seems to be the key. But to be honest, I'm a little fuzzy on how it actually works.
Well, imagine you want to send a secret message to someone, but you're worried about someone eavesdropping. Traditionally, you'd encrypt your message with a secret key, and only the person with a matching key could decrypt it. But the problem is, how do you securely share that key in the first place? That's where QKD comes in. It leverages the principles of quantum mechanics to create a key that's virtually impossible to intercept or copy.
So if someone tries to peek at the key, it basically self-destructs.
In a way, yes. The very act of observing the key alters its state, alerting both the sender and the receiver. That's something's fishy. It's like having a tamper-proof seal on your message.
That's pretty incredible. So if they can get this QKD working in space, it would be a huge step towards achieving those unbreakable communication links they're promising.
Absolutely. It would be a game changer for everything, from military operations to financial transactions to, yes, even those video calls with lunar researchers.
Okay, I'm starting to see why they're so excited about this QKD. But let's move on to phase three, because this is where things really start to get real. They call this initial deployment.
Right. This is where they take those prototypes they've been developing
Yeah.
and actually put them into orbit. It's a small-scale deployment, a pilot program, to test the system in a real-world environment. It'll be fascinating to see what they choose to focus on in these initial deployments. Will we be demonstrating secure communication between ground stations and satellites? Or maybe testing the AGI's ability to autonomously manage a small cluster of satellites?
I guess it's a bit of both, right? They need to prove that the individual components work, but they also need to show that the system as a whole can function as intended.
Exactly. And this phase is all about gathering data, identifying any weaknesses or vulnerabilities, and refining the system based on real-world performance. It's a crucial step before they can even think about scaling up.
Right, because phase four is full-scale deployment, and that's where they really start to go big, right?
That's where they ramp up production, launch hundreds or even thousands of satellites, and start building out the network on a global scale. This is where they start realizing their vision of providing ubiquitous connectivity from Earth to orbit and beyond.
But it's not just about quantity, right? They also mention implementing some advanced technologies in this phase, things like debris tracking and mitigation protocols.
Right, and remember all those challenges we talked about earlier. The space debris problem, the need for sustainable energy sources, the risk of cyber attacks. Well, this is where they start rolling out their solutions. You're talking about using AI-powered systems to monitor and track space debris, developing new propulsion systems to reduce reliance on traditional fuels, and implementing multi-layered security protocols to protect the network from hacking.
So it's like they're building a space infrastructure that's not only more advanced, but also more responsible and sustainable.
That's the idea anyway.
Yeah.
Trying to address those potential problems
Can you-
before they become major obstacles.
Okay, I'm following you. So we've gone from concept design to technology prototyping to initial deployment to full-scale deployment, which brings us to the grand finale. Phase 5, future innovations. And this is where things really go off the rails, in a good way, I hope.
This is where they start pushing the boundaries of what's possible. We're talking about interplanetary communication networks, enabling seamless communication between Earth, the Moon, Mars, and even beyond.
So no more delays in communication with Mars rovers or astronauts.
Exactly. Real-time data from across the solar system, telepresence robots exploring distant planets, maybe even virtual reality tours of alien landscapes. It's mind-boggling to think about.
It really is. And then, as if that wasn't enough, they throw in space-based manufacturing, building entire factories in orbit. I mean, come on, that's straight out of science fiction.
It does sound like something out of Star Trek, but there's a certain logic to it. Imagine being able to harness the near-limitless energy of the sun, the microgravity environment, and access to resources mined from asteroids. You could potentially manufacture things in space. They're simply impossible to create on Earth. Things like ultra-pure crystals for advanced electronics, massive lightweight structures for space habitats, even new types of pharmaceuticals with unique properties.
Okay, I'll admit that's pretty compelling. But let's be realistic here. Building factories in space. Isn't that a bit premature? Especially when they haven't even finished building the network itself.
It's definitely a long-term goal, and the technology is far from mature. But that's the point of this phase, right? It's about looking ahead, exploring what's possible, and laying the groundwork for the future. They're not saying they'll have orbital factories up and running next year, but they are saying that this is the direction they're heading.
Okay, I'm starting to see the bigger picture here. This Galaxity proposal is not just about building a better satellite network. It's about building an entirely new space ecosystem with communication, transportation, manufacturing, and who knows what else. It's like they're creating the infrastructure for a whole new era of space exploration and utilization.
That's a great way to put it, and it raises some pretty fundamental questions, doesn't it? Questions about who controls this new ecosystem, who benefits from it, and what the long-term implications are for humanity.
Right, because all this amazing technology, all this potential for progress, it doesn't exist in a vacuum. It's going to have a profound impact on society, on the economy, on geopolitics. And that's what we need to explore next. Because as fascinating as the technical details are, it's the human side of this equation that's really going to determine whether Galaxity is a utopia or a dystopia.
Welcome back. We've spent the last two parts of this deep dive getting into the nuts and bolts of Galaxity, this ambitious plan to not just improve satellite networks, but really revolutionize how we use space. But let's step back for a second. Even if they pull it off, even if the technology works exactly as promised, is this really the future we want?
Yeah, I think that's the most important question we need to be asking right now. It's easy to get caught up in the excitement of all this technological innovation, especially when it's promising such amazing things: global connectivity, space-based manufacturing, real-time communication across the solar system. It's mind-blowing stuff. We can't just blindly charge ahead without considering the potential consequences. So let's play devil's advocate here. What are some of the potential downsides? What could go wrong with Galaxity, even if it's a success from a purely technical standpoint?
Well, one obvious concern is the concentration of power. Who controls this network? Is it a single corporation?
Yeah.
A group of nations? Or some kind of international consortium? And how do we ensure that this power isn't abused?
Right, because we've seen what happens when powerful technologies end up in the wrong hands. It's not hard to imagine a scenario where Galaxity is used for surveillance, censorship, or even weaponization of space.
Exactly. And even if the intentions are good, there's always the issue of unintended consequences. What happens to existing space-based industries? What about the environmental impact of launching thousands of satellites? And how do we prevent the further militarization of space? These are all complex issues that need to be carefully considered.
And then there's the whole question of equity. Who benefits from this access to space? Is it just the wealthy nations and corporations? Or do we find ways to ensure that the developing world also shares in the benefits?
That's crucial. We can't allow Galaxity to become another example of technological advancement, exacerbating existing inequalities. We need to think about how to make this a future that benefits all of humanity, not just a select few.
You know, it strikes me that a lot of these concerns aren't really about the technology itself, but about how we choose to use it. It's almost like a mirror, reflecting back our own values and priorities as a society.
That's a very astute observation. Galaxity, for all its technological complexity, is ultimately a human endeavor. It's a reflection of our dreams, our ambitions, and, our fears as well. And the future it creates will be shaped by the choices we make today.
So what are those choices? What can we do to ensure that Galaxity leads to a positive future for everyone?
Well, first and foremost, we need to have open and honest conversations about the potential risks and benefits, we need to engage with policymakers, scientists, ethicists,
Yeah.
and the public at large to develop guidelines and regulations that promote responsible use of this technology.
So it's not just about the engineers and the entrepreneurs, it's about bringing everyone to the table and having a collective conversation about what kind of future we want to create.
Exactly. And that conversation needs to start now, before Galaxity becomes a reality. We have a unique opportunity to shape the future of space exploration and utilization, but only if we act thoughtfully and responsibly.
So to our listeners out there, this isn't just some abstract thought experiment. This is a very real proposal with very real implications for all of us. And the choices we make today will determine what kind of world we inherit tomorrow.
It's easy to get swept up in the excitement of a project like Galaxity, but we can't lose sight of the bigger picture. The future of space is ultimately the future of humanity, and it's up to all of us to ensure that it's a future we can all be proud of.
This deep dive has taken us from the mind-bending world of quantum computing to some of the most profound questions facing humanity. And as always, it seems like the more we learn, the more questions we have. But that's the beauty of exploration, isn't it? It's about embracing the unknown, challenging our assumptions, and never stopping asking questions.
Absolutely. The future is not predetermined. It's something we create together through the choices we make and the actions we take. And the conversation we've started here is just one small step in that journey of shaping the future of space and, in turn, the future of humanity.
Thanks for joining us on this deep dive into Galaxity. We hope it sparked your curiosity, challenged your thinking, and left you with a sense of wonder about the possibilities that lie ahead. Until next time, keep exploring, keep questioning, and keep looking up at the stars.